This problem has to do with finding the mean of a frequency distribution. So see how in this case you have data and you have a range of values. In this case they're talking about speeds and how many cars were found going at a certain speed, I guess, on a highway. So they say find the mean of the data and summarizing the given frequency distribution. Okay, so what we have to do to find the mean is, well, first of all, I'm not really sure what the equation is, so I'm going to click on view an example here, and I'm going to hit continue, and oh, here's the equation. To find the mean of a frequency distribution, you have to take the sum of each frequency times the midpoint of each one of those ranges and divide it by the sum of the frequencies. So okay, let's remember that. We'll close that for now. So the first thing I'm going to do is copy my data over into Excel. And I'm going to say okay, and I'll have an Excel window open and copy it over. So there is an x involved in that equation, and the x is the mid-range of each one of the ranges. So I look at each one of the ranges. Here's the 42 to 45 mid-range. So first of all, I'm going to call this x, this column. So what's halfway between 42 and 45? I think it's 43.5. What's halfway between 46 and 49? It's 47.5. And as we go down, I believe we can just keep adding 4. See how we're adding 4 as we go down? So 55.5. And the last one's going to be 59.5. So we got that column complete. But as I recall, the equation said we have to multiply each frequency times the midpoint. So we're going to have I'm going to come back over to Excel, and I'm going to have an fx column heading, f times x. So I come to the cell right below the column heading, and the first thing I do when I'm going to type an equation into Excel is I put an equal sign. And then in this row that I'm in, I find f, the frequency. And oh, I think it's right here. It's the 26. So I don't type 26. I click on the 26. Times in Excel is star. And where's the x in this row? It's the 43.5. So I click on it, and I hit enter. And that did the multiplication for me. You don't want to repeat that for each one of these. So the trick is you highlight the guy we just got, the 1131. You move your mouse till your cursor becomes a black crosshair. You left mouse click and drag down. Oops, I gotta go one more and release. Okay? So then if I recall, the equation said we had to add up our f times x's. So I'm going to go to the bottom of that column and go to my little auto sum button over here and then just hit enter. And it added that up for me. I think we also had to add up the frequencies. So I'm going to go to the bottom of the frequency column, and I'm going to do the little sum thing too. Okay, now I kind of forget, so let's go back and look at the view the example, say what was the equation? You take the sum of the f times x's divided by the sum of the frequencies. Okay, so I'm going to come back over to Excel, to any cell that I want. I'm going to put an equal in. Where's the sum of the f times x's? That's the 2,331. And then I'm going to divide it, use the forward slash, by the sum of the frequencies. 50, hit enter. I got 46.62. It says over here to round it to the nearest tenth, so I'm going to type in 46.6. That's rounded to the nearest tenth. Hit enter. Fantastic. Good. I'm going to hit continue on the problem, and it says which of the following best describes the relationship between the computed mean, which is 46.6, and the actual mean, which was 51.5, given up there. Let's see, the computed mean is not close to the actual mean because the difference between the mean is less than 5%. The computed mean is close to the actual mean because the difference between the mean is less than 5%. I got to figure out if it's within 5%. How do I do that? Well, what we can do is we can open up our calculator and we can figure out, let's see, the actual mean is 51.5, and we can subtract what we got, the minus 46.6, get the difference, divide that difference by the actual mean, which was 51.5. And what does that give us? That gives us 0.09. So if we multiply that by 100 to get it into percentage, we have, it's a difference of 9.5%. So that's greater than 5%, so I can get rid of this calculator. Let's see, which of the best describes the relationship between the computed and the actual? Well, the computed mean is not close to the actual because the difference between the two is more than 5%, right? So I believe it's C. So let's try C, and we'll check our answer. Good job.